In this lesson we're going to continue to look at energy level diagrams. This time we're going to quantify things a little. We're going to look at a specific reaction, which is the reaction of hydrogen with chlorine to form hydrogen chloride. We looked at this in a previous lesson in the context of bond breaking, and so we're going to do the same thing now and apply that to the energy level diagram. So the energy level diagram for this reaction will look like this. This is an exothermic reaction, so as you know, the reactants, that's the hydrogen and the chlorine gas, are at the higher level, and the product, which is hydrogen chloride, is at the lower level. Okay, so what happens in the first stage of the reaction is that the bonds of hydrogen and chlorine have to be broken. So we remember that when that happens, that requires energy. That is an endothermic process, breaking the bonds of hydrogen, and likewise, in the case of the chlorine molecule as well, the covalent bond has to be broken into two chlorine atoms, and that also requires energy, so that too is endothermic. So the breaking of these bonds involves a specific amount of energy. We learnt that in the last lesson, and in the case of hydrogen, that change in enthalpy, delta H, is positive, it's endothermic, and it's 436 kilojoules per mole. And in the case of the chlorine molecule, less energy is involved. The energy required to break this bond is 242 kilojoules per mole. So I've written the plus sign in here to emphasize that these are endothermic processes. Energy is absorbed in order to break the bonds, and the total energy absorbed in breaking the hydrogen and chlorine molecules is the sum of these two figures, which is represented by the up blue arrow here, and so we can write that the change in enthalpy in the bond breaking process is equal to 678 kilojoules per mole. So in the next stage of the reaction, the individual atoms then react with each other. The hydrogen will react with the chlorine atom to form hydrogen chloride, and this happens twice. So effectively, this atom reacts with this chlorine atom, this atom reacts with this chlorine atom, and we can write H plus Cl gives us HCl, hydrogen chloride, and the change in enthalpy for this process is negative. That means that energy is released in the forming of the hydrogen chloride bond, and in each case the energy released is 431 kilojoules per mole. We remind ourselves that this happens twice because there are two hydrogen chloride molecules formed. So we repeat that while doing our accounts, and the total energy released in the formation of the hydrogen chloride molecules is the sum of these two figures, which is delta H equals minus 862 kilojoules per mole. And so the total enthalpy change for this reaction is the energy required to break the bonds, again that's represented by the up blue arrow, minus the energy released when the new bonds are formed, that's represented by the red down arrow, which is equal to 678 kilojoules per mole minus 862 kilojoules per mole, which is equal to a delta H, a change in enthalpy of minus 184 kilojoules per mole. So the overall change in enthalpy for the reaction of hydrogen with chlorine gas to produce hydrogen chloride is minus 184 kilojoules per mole, which tells us that the reaction is an exothermic reaction.